Unknown caller. Unknown caller.
Okay, let's minimize this. It's supposed to be first. All right. Okay, can everybody see my screen? Oh, no. Let me share my screen. Okay. Let me bring up the chat. Where's the chat? Oh. Right here on one side. All right, everyone, welcome back. Let's see, let's take a look at the syllabus, see where we've been, where we are, and where we're going. Let's see, we're getting started on our 11th week. We just chatted last week about optimizing the database using indexing and talked about how we can have multiple users use the database simultaneously using transactions. So this week we're going to be talking about non-relational databases. We spent 2/3 of the almost the entire semester talking about relational databases, right? How to come up with a data model that could be then mapped and implemented using relational database, in particular MySQL. And there's plenty of other types of databases of which that don't use SQL at all and are not relational. And so we're going to be talking about one particular non-SQL or non-relational database. In particular, we're going to be talking about MongoDB and how to interact with it programmatically using Mongoose. Let's see. Let's question on the chat. Professor, where can I find your contact number? I was looking for last week. Oh, yeah, sure. Here's my phone number. Yeah, that's my personal phone number. Feel free to chat, to send me a text or even call me. But that is my personal number, so please don't share it outside of this lecture. Let's see. Yeah, so today we're going to be spending some time talking about non-relational database and what kind of problems are they trying to solve. We'll talk about relational databases were designed at a time where there was a specific type of there were different types of problems that relational databases was trying to solve, and we'll see how non-relational databases falls in that history. Then we'll talk about Firebase. Probably get to it on Friday. Perhaps it'll spill over to next week. So we can talk a little bit about Firebase. It's also a very exciting alternative to a relational database, and so that might spill over to next week. And then next week we'll get started discussing more and more about the project and how to implement certain aspects of the project, in particular, how to do one-to-many, many-to-many, one-to-one, how to implement multiple things that you'll need for your project. If feel free to come with questions on how is that you're implementing your own project. And I also have several other topics that we can discuss. If I see that everybody's doing very well with a project, we might as well cover more material. Okay. But I did want to give myself enough time to help folks work on their final projects as they're working with other teammates. Okay. Also, there'll be a quiz later this week, and there's a new assignment, the non-relational assignment, which will be released later today. I think that's it. Any questions? So you should be fully working on your projects or as teams. Coming up with a problem that you want to solve together. Coming up with a data model, a design using UML diagrams, and you're expected to have some kind of implementation, at least for the relational database and the UML diagram for next week. And so, hopefully you are working towards that goal, right? And obviously, you don't need to ask for permission of whether this particular project is okay or not, as long as it meets the requirements that we went over together late last week, right? That it has to have so many one-to-many relationships, many-to-many relationships, relationships between users, or relationships between users and domain objects. As long as it meets those criteria, you're free to pretty much implement anything you want. And again, for the assignments, we are asking you to use a specific database, which is MySQL, and we're asking you to use the relational database, right? We're asking you again for the assignments. We ask you to use the ORM for Java and Java programming language. Also for the front end, we've looked at React.js and JavaScript, but so that's for the assignment. But for the project, you're unconstrained, right? You can do pretty much what you want, right? For the front end, you can choose whatever technology you feel more comfortable with. For the middle tier, if you prefer to use Python, Ruby on Rails, or use any other stack, please feel free to explore those. If you don't want to use MySQL and you prefer to use Oracle or SQL Server, or a non-relational database that you've played around with at work, feel free to use that. So it's more open-ended, right? You get to choose your own story there. So yeah, that's for the project. For the project, it's pretty open-ended. For the homework, obviously, because we have to grade you with very specific requirements, it's you have to follow our lead. All right. Any questions? All right. So if there are questions, let's talk about MongoDB. All right. So MongoDB is one of many different types of databases that fall under the broad umbrella of non-relational databases, right? So relational databases became very, very popular and still are, and probably will be for quite a while. But at the same time, there are many other alternatives that folks were exploring, and that did not were not used for creating relationships between records. Yeah. So, for instance, there are databases for that for capturing real-time data, right? That perhaps they're measuring wind speed or temperature or depth or the content of oxygen in a chemical reaction. They're reading all this information real time, and it's being stored in some form so that folks can query and make analysis where they can look at trends, how the oxygen is increasing, and how the CO2 is changing, or as the chemical reactions are happening in real time, and they want to be able to identify what the relationships are between this chemical and this other chemical, and the temperature and the pressure, and so these real-time databases are completely different in fundamentally on how relational databases work, right? In relational databases, we're looking at data that is mostly static, right? And we are doing some updates here and there. But for the most part, the information changes very, very slowly, right? And it's stored for long-term period of long-term storage, so that if we come back tomorrow, we are guaranteed to see the same or fairly the same information that we saw yesterday, right? So it's stored for a long time, as opposed to real-time databases don't store the data for long periods of time, right? They usually are stored for a very small amount of time, maybe for a minute, an hour, a day at most. Okay, where you have tons and tons of data points that for that day, and there's a window of interest where you see the data just changing over time, and you want to graph it. Maybe you want to relate the change of one variable against another variable. You can do queries to find averages and trends and fitting curves and things like that. So it's a completely different set of problems. Okay. Likewise, there's databases for that have geographical information, right? That again, the way they're stored is using graphs, and we're interested in distances between different points on Earth, right? And so the way they're stored and the kind of queries that you do to these databases is completely different from what you do for relational databases, right? They're databases that are hierarchical, right? That use XML as for storage purposes, and how the data structure is in a hierarchy, in nodes, right? That are connected in a graph. Right? So there's many different other types of databases that are not relational databases, right? So in particular, we're going to be looking at MongoDB, which is one of many non-relational databases that are out there. I encourage you to explore more on your own, such as databases such as Cassandra, CouchDB, Redis, DynamoDB, Firebase. Let's put Firebase here as well. Firebase, and definitely explore all these other alternatives that have been out there that are not perhaps as mainstream as relational databases. Since relational databases has been with us for quite a while, and have been the dominant type of databases that folks have been studying and using, and in industry. And so they're great for commerce and they're great for relational databases is great for when you are very certain about the structure of the data, right? And that structure of the data will not change dramatically over time, right? You understand that users have a first name, have a last name, have a username and password, right? They have an email. And that structure very, very well, right? That they're related. They have several addresses. They might have an account, right? They might have a profile. They're related to different courses that they're taking or courses that they're teaching and things like that, right? But the structure is very well known, right? And it changes very little over time, the structure of the data. Whereas you have other types of data that have no structure, have very little structure. And that's where these non-relational databases shine, right? So in particular, for instance, now that with the advent of all these online services that folks are generating gobbles amounts of data that are not necessarily structured. I mean, every time we pick up our phone and we wiggle it in the air, we are getting a stream of data that somebody is storing somewhere, right, in a database. Okay, and folks are trying to relate that information with other information, right, about my geographical location and my history and my search online and what I've bought in the past and what I like, different things that I like online. So all this information is very, very unstructured, and we are trying to create find the structure of the data over time, right? And so we need databases that allow the flexibility of dealing with unstructured data that in huge amounts of it, right? Huge amounts of it. So with the advent of all these applications going online and creating this huge amounts of data every time you watch Netflix or you post something on Twitter or whatever, all this information, right? It's growing exponentially, and there's most of us don't know what that structure is, and so usually we look for algorithms that can traverse through this huge amounts of information and extract usable data, right, and identify what the structure of this data is at a later time. So MongoDB is one of those databases that has, for instance, has no schema. There's no schema that you specify and then you validate against that schema, right? You can change the schema anytime you want, right? So it's a very different way of thinking about data storage and retrieval. We will be using a lot of the same things that we've learned in relational databases and apply it to MongoDB, at least at the beginning, so that we can understand, from what we've learned so far in relational databases, how is it applicable or implementable using a non-relational database. And we'll contrast, how would you implement certain ideas that we've been studying in relational databases, and how would they apply in a non-relational setting. Okay. So first of all, we'll need to download and install MongoDB. So to do that, you can head over to MongoDB, right, and paste it in there. And so this is the landing page for the MongoDB database, and they offer a they offer a paid for service, right, where you can host your database with them, and that's fine. We can absolutely use that. You can also host the database locally on your machine, and that's what we're going to do. Right? We're going to download the database onto our local machine and start running it locally, so that we can play around with the database locally on our machine. Okay, as opposed to having this running in a as a service. Right. So you can download it from here. There's a community version of the database. Let's see. Yeah, and so you can download it for your database, for your application. I mean, your operating system. You can select the whether it's Windows or Mac or whatever it is. You download it, and once you download it, it's a zip file, and it gets you unzip the content of the zip file, and then you can put it either in program files. Let's see, where is it? MySQL, where to go? Mongo, there it is. MongoDB. So I put it here. You can really put it anywhere you want. It doesn't matter, as long as you know where you put it. Right? Make sure wherever you unzip it, right? Make sure you remember the directory where you unzipped it. Okay. A very common place to put it in Windows is under program files, MongoDB, and in there there'll be several directories. Eventually, the last directory will have a bin directory like this. Okay. On a Mac, same thing. You would unzip it. Again, it doesn't really matter where you put it, but a common place to put it on a Mac. Let's see. Do I have that here? Let's see. Usually on a Mac, a good place to put it on a Mac is under /user/local. So that's a common place to put it. So at the end, you would end up with user local Mongo, right? And then there will be a bin directory under there, right? On Windows, a common place to put it is under C program files, And again, there will be a bin directory under there. On either way, whether you use Mac OS or Windows, that bin directory needs to live on your path. You have to add it to your path. On Windows, the way to add it to your path, so this bin directory, we need that bin directory in your path. So the reason is that under that directory, there's a couple of executables that we want to be able to run and use from our command line, right? In particular, there's two of them that are of interest. One of them is MongoD right here. See that, MongoD? And the other one is Mongo. So these two, MongoD and Mongo. So MongoD is your database server, right? This is the same thing as in what the same setup that we have for MySQL, right? MySQL had the server and it had the client, right? The server is the one who was responsible for actually storing the data, and then the client connected to the server. And for us, the client that we're using for MySQL was a workbench, right? And you had to create a connection, log into the database, right, and start interacting with the server, right? So you had two. You have the server, who's responsible for actually storing the data, retrieving the data and whatnot, and then you have the client that connects to the server, right, and communicates with it. Same thing here in Mongo. So we have the MongoD. The MongoD is the server, okay? Whereas Mongo is the client. Okay? Both of them are command line executables, and they're the same thing on Mac and on PC. Right? You have MongoD and Mongo on both. Okay. Now on a PC, we need to add this bin directory to the path, and to add it to the path is very simple, right? You go to your environment variables, system environment variables, and in there, in the path, you can add the location of Mongo, and there it is. See that? I've added MongoDB server 4.4 bin directory to the path. Okay, so it's already on the path for a PC. On a Mac, it's slightly different. You have to edit your bash profile and export the path in your bash profile. It'll all be explained as part of the assignment. It'll walk you through this when the assignment is released. Okay, but just so you know, all right. So once you've done that, you can then start your Mongo server, right? So let me demonstrate that. So what we're going to do is that we're going to first start not that. Let's start PowerShell. So let's go into NEU, and let's go to DB design. And in here, right, we're going to do our assignment here. We're going to create a directory, and we're going to do all our work under that directory. Okay, so I'm going to say, make directory, and this is our MongoDB assignment, or dash, I guess. So let's go in there. Right now it's empty. There's nothing in there. And so what we're going to do is we're going to create a directory here where we're going to put all the data for the, as we interact with the database, we're going to put it all under here. So we're going to create a directory under here. So make directory data. And so now we have the data directory. And we're going to start the server and tell it to store all the database, all the data that we're storing in that directory. Okay, right now the data directory is empty. There's nothing in there. But can I make this bigger? What? Oh, there we go. So let's start the server. So to start the server, after you have added Mongo and MongoD to your path, right? You can just run MongoD from the command line. You can say MongoD, and then you can tell it where to store the data. So and the way you do it is you use this option, -- db path. right? --db path, and then the directory that you want to use for the database. Okay, so there it is. So the database started. Let me stop it for a second. Clear. Okay, let me do that again. Okay, so you can see clear. Okay, there it is. Okay, so when it starts, it's going to look for that data directory, and if it can't find the data directory, the server is going to stop working. Okay, it's going to say shutting down. I didn't find the data directory. Sorry, I can't work without the data directory. Okay, if instead if it finds it, it spits out all this content, right? And at the end, towards the bottom, you'll see that it's listening. It says listening at port 120. Listening at port 27,017. See this? Okay, so it's listening at a local host, and then the port is listening at 27,017. See that? So that means that the server is running, right? And notice that it's locked, right? So, it doesn't let me type anything, right? So this means that the server is running. Okay. If instead it would have shut it down, it would have come back at the command line where I can type, right? So yeah, leave it running. Let's run it again. Okay, now it's running. Leave it alone. And so every time you want it to work with the database, you need to start the server. You can also configure it to run as a service, so that every time you boot up your computer, right, it will automatically start. But since we're going to be working with this only like for one assignment, I don't know that you want to start this as a service and leave it running forever. Instead, every time you want to run it, just come to this directory, your assignment directory, right, and run it from there. MongoDB, and then DB path, right, and then data. So it's running. Leave it alone. So in a separate tab, right, in a separate tab or a separate window. Let's see. Can I start a new one? Tab? No. So I'm going to just start another PowerShell. So in a separate PowerShell, from anywhere, right? It doesn't need to be in that directory. Although I guess it's a good idea to work in the same directory. So I'm going to go into that directory again. So I'm going to go to Documents, NEU, and DB Design. And let's see, we'll go into the Mongo assignment. So this directory is where the server is running. So it's running in this directory. Okay. In the same directory, we're going to start the client application. The client application, this is the equivalent of Workbench. Okay. Now Workbench was a nice graphical program, right, that allows us to see the tables on the left, right, and then we could create a new table, do inserts using the graphical interface, right, and then we would click on apply, and it would send all the changes over to the server. So we're not going to do that, right? Instead, we're going to use this non-graphical tool, right, which is all going to be all command line. It's all going to be all keyboard and mouse. Okay, and let me make this bigger a little bit so we can see. Okay, we're going to start the command. So the command is Mongo. The other was MongoD. This is Mongo without the D. Okay, so when you type enter, notice that it tried to connect. Blah, blah, blah. So anyway, so notice that it's giving me a prompt. Okay, if it gives me a prompt like this, that means that it was able to connect to the database, right? If it wasn't able to connect to the database, it'll quit. Okay, and put me back in the command line of the operating system. So we're good, right? It's now connected to the running server. Okay. So while we're here, we can issue several commands that allows us to interact with the database, right? So let's take a look at the slides. Okay, so So here the instructions on the slides ask you to create a directory called data and then a directory under there DB from the root, right? And you can certainly do that. We could certainly create one single directory and put it at the root. The problem that I found with this is that on newer versions of macOS, you're not allowed to do that. The new I think it was Catalina or Big Sur, I forget. Actually, you have to have super user administrative privileges to create directories off of the root. So I tend to instead create directories elsewhere, not from the root, so that where I don't need special permissions. So if you know how to use a sudo on Mac OS, then certainly try that. If not, just create the directory elsewhere and use the db path option. Okay. So also I've seen that for Mac OS, even to start the server, you might need to use sudo. Right? Sudo means super user, and which allows you, it'll ask you to log in and give your credentials, and to start the MongoDB server. Okay. Anyway, I'm suggesting that instead of adding the directory to the root, you create your own directory elsewhere, under your assignment directory. Okay, and then you can provide the path using the --db path option. Okay. All right. So yeah, I suggest doing this at least for the assignment. So when it starts off at the end, it says that it's listening at port 27017. Okay, so now we're good. It's running. Right. Once it's running, we can start to serve the client. Here we've started it using Mongo, and let's learn just a couple of commands to interact with the database. The first command that we want to learn is show the databases that we already have. Right? So if we go here and we do show DBs, notice that at first it's empty. Right? There are no databases. Well, I'm sorry. There are these three databases. These are the default databases that come with the server when you first started, and it's the very first time that you're using it. There are admin, config, and local. So those are standard databases that are already there. Okay, so we're going to create our own database and do our work in there. And so to create our own database, it's very easy. We're going to use this as an example. This is based on the university database that we started looking at early on in the course, right? We were talking about users, faculty, students, and courses and sections and enrollments. So let's do some work in that sense. Okay, so for instance, we can create a database by saying use. See that? See, it says use, and then the name of the database that you want to use. Okay, which is very similar to what we do when we work in MySQL. In MySQL, it's the same exact command. You say use, and then the database, the schema that you want to use. So let's do that. We say use, and we say whiteboard. The name whiteboard comes from my initial contempt against Blackboard. Blackboard is the online learning management system that we were using about a year ago, and I absolutely despised Blackboard. I don't know how you feel about it. And so I started playing around with implementing my own online learning management system, and we play around with that idea in my web dev class, and we implement a database. We implement an application called Whiteboard, in contrast to Blackboard. So there we go. So we're going to use Whiteboard. Now, notice that it says switch to Whiteboard, but even though it says that it's switched to Whiteboard, if you do a show DBs again, notice that it doesn't actually show it. Right? Notice that even though you are in the Whiteboard database now, it doesn't actually show it. Not until you actually store data in the database will show that you are in the whiteboard database. Okay, so that's one of the first things we're going to do, is that we're going to start inserting and creating data in our database, right? So these are the four commands, most common commands that we're going to be using to interact with the database, right? Which are very, basically they are the same CRUD operations that you will find in any database, right? Any vendor, any solution that you will find, right? It all comes down to these four operations: being able to create data, retrieve the data, update data that already exists, or remove data that already exists, right? So those are the four commands. And the syntax for using these commands is as follows. All the commands start with DB, okay? Then the collection. So the collections are the equivalent to tables, right? Instead of tables, we call them collections here in MongoDB. And then once you specify the collection or the table, right, you can then specify the command. And the command can be either to insert data into the collection, find data, so retrieve data from the collection, or update data in the collection, or remove data from the collection. Okay, and then you provide the actual data and arguments as parentheses, parameters, right, to that command, right? So let's play around with this idea. Let's start with inserting a few users into the database. Okay, so let's insert our first user, Ada Lovelace. Ada Lovelace is considered to be one of the first or the first software developer. She was one of the who was helping Babbage, to code one of the first computers, right? So she technically is the first programmer ever. So let's insert Ada. So let's do that. So the way we're going to do this, we're going to set the command. Remember, all the command starts with DB, right? DB, and then dot the collection we want to insert into, right? So we want to insert into users. We're going to follow the same naming convention that we use for MySQL. Although in MySQL, MySQL is case insensitive, whereas MongoDB is case sensitive. So you can use capitalization here, right? But we're gonna follow kind of like a mixture of the two, right? So collections are all going to be nouns, and they're going to be plural, right? Just like you have in MySQL. But the difference here is that because it's case sensitive, you can use capitalization. If you're going to have something, a compound word, right? You can certainly use capitalization to separate those words, right? So db.users, and then we want to insert something into the user. So we're going to say insert. And then in that insert, we can then specify the data that we want to insert. Okay. Now, the format of the data that we're going to insert is going to be formatted using JSON, right? JavaScript object notation. You might say, well, why JSON? Why JSON? Why JavaScript? What the heck? Well, it turns out that JavaScript is making a huge splash in software development. Definitely it's taking over the front end development, especially for web applications, and they're kind of like the #1 client, right, for data consumption, and many applications are making their way towards the web, as a means of delivering software, right? First the software was delivered in the form of mainframes, right, and you had one single piece of software, stored in a huge mainframe, and folks would log in with these rinky-dinky, dumb terminals, where you would type something, and everything you would type would be sent to a centralized server, right, which would interpret your commands and then spit out some results to your terminal. Then we switched over to desktop, right, PCs, where everybody had a machine, personal computer on their desktop, And then software started to be delivered in the form of disks. You know, the small, 1.4 megabyte disks. And then, we switched over to many different types of storage. Eventually, we use DVDs or CDs, where software was delivered, physically in these memory storage. So now we seem to be full circle, going back to like a centralized server, right, where a software is installed in a central server, and then we download the application from this server, and that runs in a browser. And so inside the browser, we have this application, which is being delivered through through this server to these terminals. And our terminals right now are browsers, right? And the language that folks use in these browsers are JavaScript driven, right? And so they want to consume the data and format it in JSON format. That's why JSON has become so popular. It used to be at the turn of the century that the most used format of data that was being passed around in the internet was XML. XML was very popular at the turn of the century, but as applications have moved over more and more to the web, with folks such as definitely Google and Amazon and Netflix and Facebook and all these huge corporations are bringing everything onto the web. Right, they have pushed a lot of these standards and pushed the industry towards the use of these kinds of clients and this kinds of data transfer. So JSON is currently the dominant format of data transfer across networks, other than perhaps binary data, right? That might be peculiar or might be specific to an application, maybe like such like maybe a game or something like that, where they might have their own protocol, they might have their own format, and it's binary and encrypted, and nobody can figure out. But for the most part, data that is being transferred back and forth between web applications and middle tier applications is JSON. So Mongo stores its data in JSON format. And we see a lot of databases that are relational, like Postgre and MySQL, SQL Server, Oracle, they also now support the JSON format. So just like there's a int data type and varchar, and this float and double and date, now there's a JSON data type, right, where you can store raw JSON in a column, right, which you can then apply all sorts of JSON related transformation. So you see a lot of the industry moving towards this, right? So yeah, Mongo in particular stores its data formatted in JSON. So what we're going to give here is we're going to insert a record, and that record is formatted as a JSON object. So JSON, as we saw, right? It's the format is very simple. It's basically a curly bracket specifies that this is an object instance, and then inside you can have several name value pairs, right? Name colon value comma name colon value comma, right? You can have any number of properties, and each property can have its value. Okay, so let's add a couple of properties. So this is a first name and colon and then Alice. And then we can have maybe comma, then last name is another property. And this could be Wonderland. Okay, and maybe a username, Alice. Okay, and maybe password. Something like that. Okay, enter. When we do an enter, notice that it comes back saying that one document was inserted. So we call these, we don't call them records, right? We call them documents. We don't call them rows, right? We call them documents. Okay, so the server return saying that we were successful in inserting one document. So again, the jargon is slightly different. We don't call them tables, we call them collections. We don't call them records, we call them documents. Okay. All right, so we've inserted our very first document. Let's insert Ada now. We forgot to insert Ada. So let's so this is Ada, and then Lovelace, and this is Ada, and same password. So we've inserted 2 documents so far. Now you can retrieve these documents and see the current data that you've inserted so far by using another command, right? Remember, there's 4 commands, 4 basic commands: insert, find, update, and remove, right? So we've used insert to insert data into our collection, right? And let's use find, right? Find is going to allow us to retrieve the data that we've inserted so far. So we say DB. Right? Remember, all commands start with DB. Then the second part of the command is the collection that you want to work with. In this case, is users. Again, we're going to use nouns and plural as a naming convention, and then dot the operation that we want to use. So in this case, it's find. We want to find all the records in the users collection. We say enter, and notice that it comes back with the 2 documents that we have inserted. You can identify them because here's the first name says Alice, last name Wonderland, and so forth. And here you have first name Ada, and then Lovelace, and so forth, right? Okay. Also notice that there is a property that we did not create, but looks like the database created for us, right? Notice here that there is a property called ID _ID. See that? And it has a value. And there's another ID here, and there's a value. Right? Notice that these values are unique. You see that? They're not the same. So what's happening here is that the property _ID, okay, was created by the database itself, right? And notice that the value is a unique value. So basically, the _ID property plays the role of a primary key. Okay, the document here, these two documents have already been indexed, so the database already creates indices for you, right? And they're indexed using this _ID, right? So that for a quick retrieval, it uses these 2 indices that it created. Okay. Also notice that the data type, it's not a string. Instead, it's its own internal data type called object ID. And notice that the naming convention is that it has an underscore in front of it. If it has an underscore, then you'll know that this is a field or a property that was not created by you, right? But it was created by the database, right? And it's managed by the database, right? So you should not screw with it, right? You should leave it alone and use it as is. Okay. So yeah. Now this is a little bit hard to read, right? Because it's kind of ugly the way it's formatted. Now you can improve the readability a little bit by appending at the end of the find command. You can append the following. You can say pretty, and then as a function, you can call the function pretty on the results of finding data from the database. Okay, so if you do enter like that, notice that it displays the same information that we had earlier, right? Here's the document for Alice, and here's the document for Ada, right? But it's a little bit easier to read. Notice that it adds tabs and it justifies everything, and now everything's nicely neat and easy to read. Okay, so yeah, so pretty is just one of many ways that the data can be transformed. There are other commands also that are useful only for human consumption, only so that you can consume the data in an easier way. For instance, you can also use sort. Sort will reorder the contents for you only for display purposes, right? Because you want to see it ordered by last name or ordered by first name or email or whatever, right? It's not actually modifying the data. It's not this, pretty is not reformatting the data at all, right? It's only for display purposes, just so that we can consume the data in an easier fashion. So yeah, so these documents have fields or properties, and then they have values. Now these values can be of different data types, right? For instance, here name is a string, age is a numeric data type, status, it could be maybe a character data type, and groups over here is an array of strings. Okay, and you can continue. You can have other fields that contain other objects, right? So whatever you can store fairly complex structured data into these records, or not records, these documents. These documents can be arbitrarily complex, right? It could be an object that contains a field, and that field could be a string, a number, an array. It could be another object, right? So it would be an object that contains another sub-object in there, and that sub-object, one of the properties, could be another object, right? One of those, and that sub-object can contain an array of objects, of arrays, of objects, of arrays. So it could be, complex, a very, very complex piece of document. That's why we don't call it a record, right? It's an entire document that has properties and values that you can retrieve as objects. Okay. So yeah, so MongoDB documents can be fairly complex, and you can modify those documents. You can in this array, for instance, you could say, oh well, that array contains 2 strings. I can add another string in there. I can push into that string. So anything that you could do with an object, of manipulating the object, the values of the properties, right, you can do also to these documents that you store in the Mongo database. Okay. Now a collection is what it says, right? It's a collection of documents. You can have many documents, and together they form a collection. Okay. So right now we only have one collection. It's the users collection right here, users, right? And just like we can show DBs, notice that if I show DBs now, because I have inserted data, right? Before, remember when we said use whiteboard, it didn't show the whiteboard. But now that we've actually inserted something into the whiteboard database, if we say show DBs, notice that now it does show that we do have a whiteboard database. Okay, before it wasn't showing it because we had not yet inserted something into the database. Another command that is useful is you can say show collections, right? And same thing. At first, this collection would have shown nothing, blank, because we had not inserted anything. But because we have inserted now something into the users collection, right? This will show that we have a users collection, right? So yeah, so not until you have inserted any data will you show the collection or the database. Okay. All right. Yeah, so collections comes back with users. All right, so we saw find, right? We saw db.users.find. It comes back with all the documents in that particular collection, right? And we saw the ID. And pretty makes it easier to read. Now, so find, when we say find like that, when we say find, notice that find can take an argument. See that? It could be it's a function that we call on it, right? So you can put parameters in there in that find function. And if you don't provide arguments like we did over here, right? We didn't provide any arguments. The interpretation by the database is that you want to retrieve every single document, right, from that collection. Okay. And that's what happened, right? It came back with the 2 lonely documents in the users collection. But if you want, you can provide here arguments or parameters to the find function, right? And all arguments all parameters to all these functions, right, are in the form of JSON as well. So the data that is stored is JSON format. Also, any parameters or arguments that you pass to these functions is also in the form of JSON, right? So for instance, this JSON configures what it is that you want to find, right? So you're finding we know already that we're finding it from the users collection, but this find here is going to allow us to specify exactly what we're looking for. Okay, so this is this curly bracket inside of the find method, right, is equivalent to the where clause. Right, so just like you say, you can select star from users. That's what this does, right? This is like select star from users. That's what this is. Okay, with no where clause. And the interpretation in a relational database is that we want to retrieve all the records, all the rows in that table. Okay, so that's this. If you want to specify the where clause, right? If you want to specify predicates, you do that as an argument to the find function, right? For instance, you might say, I want to find, right, not all the users. I want to find the users that match the following criteria. I can say, I want the one who has a first name that is equal to Alice. Like that. See that? And if I say enter, notice that it comes back with a single document, right? Because Alice Wonderland is the only one who matches that criteria. That makes sense? Right. So in here, you can provide a JSON object that encapsulates the criteria by which you want to filter the documents that you're looking for. Okay. You can also retrieve things by their ID. Let me show you. You can say, I want the document whose ID is equal to. Now, let's say we want to retrieve not Alice, but Ada. So this is a string that we want, right? And yeah, you would say that you think that it would be something like this, right? ID equals, right? And that long string, right? But that's not the case, right? Because this is not a string. This is not a string, although it's built out of a unique string, yes. But the way we specify is that we say that string actually it's an object ID. Object ID like that. Okay, and then we can say enter, and wait, something is it not object ID? Object ID is not defined. What?
Missed the T, object.
Oh, okay, thank you. Can't spell today. Object. I hate computers. They always take everything so literally. They always do exactly what you're told. Okay, so there it is. So notice that we were indeed able to retrieve that document by its ID. Okay, everybody good? All right. So yeah, so we can retrieve things by their ID, or we can retrieve them by some key. I'm sorry, non-key field, right? So this is retrieved by their key field, ID, and this one is by some username or by first name or last name or whatever. Okay. You can also specify in the second argument. So this first argument specifies the filter. Right? How do you want to filter? We can specify a second argument. The second argument, right? The second argument here, you can say comma. The second argument is the projection. Okay, remember projection when we did algebra, right? Relational algebra. If you remember, there was a select. This is a select. So dot find implements the select, right? In relational algebra. Here, the second argument is going to implement the projection operation, right? If you remember the projection, so the select operation filtered the data vertically, right? It said, well, here are all the records, and what the select statement allows me to provide a predicate and to specify exactly, which records I want from the table. I don't want all the records. I only want a few records, only the ones that meet the criteria. Okay. and it comes back with all the columns. In this case, right, it's retrieving this one record or document, and it's retrieving all the properties. So projection, if you remember, projection returned the same rows, right, from a query, but it filtered horizontally, right? It said, which columns do you want? Right now we have, 1, 2, 3, we have 5 columns. Projection allows you to say, well, I don't want all the columns, I only want a few. So here you can say, for instance, I want the last name, and say last name, okay, and I want that, I'm going to say 1. So 1 means I want it. I want the last name. Notice that I'm not including any other fields here, right? Any other property. When I'm not including first name, I'm not including password, username, right? So I'm saying that I only want the last name. Okay, if I do enter, notice that indeed it came back with the last name. Notice that it did not come back with the first name or the username or the password. See that? But it came back with the ID, even though I didn't specify that I wanted it. By default, ID ignores the projection, right? If you specifically don't want the ID, okay, so ID is by default included, right? Even if you don't include it in the projection. The thinking is that you're going to need the ID anyway. In most cases, you're going to need the ID of the document that you're retrieving. But if you insist, if you do not want the ID, you can specify, you have to explicitly specify that you don't want the ID, right? And you specify things by saying, provide the field and say, no, I don't want it, with a 0. I don't want it. And now we only get that document with that one column or with that property last name. That makes sense? Everybody still with me? Yeah, so find takes 2 arguments. The first one is the where clause, right? And the second one is the projection clause. Okay. All right, so let's start implementing a couple things here. Let's start implementing these sections over here. Sections. Okay. So let's insert a couple of sections, and let's assume that there are existing courses, right? Let's not get into that just yet. And so let's insert into the sections a course whose name is 101. It has 12 seats, and the course, right, is CS101. Now this course 101 almost feels like it's a foreign key, okay? And even though you can specify values, right, that have a value in one collection that match values in another collection, okay, and indeed those could be references, could be logical references. They're different than logical references in relational databases. In relational databases, those foreign key, primary key relationship between records is used so that you can join, right? Where you can say, hey, retrieve some fields from this table and some fields from this other table, where the foreign key of one of them is equal to the primary key of the other, right? And then it'll do a merge of the fields from both tables. Not here, right? This is not a relational database. Even though this might really refer to an existing course, right? It is not treated as for implementing joining or anything like that, right? There's no such thing as a join in a non-relational database. If you want something like that, you'll need to implement it yourself, right? And we'll see how to do that a little later when we looked at tools such as MongoDB. I'm sorry, not MongoDB, Mongoose. Mongoose is going to be a library, right, that uses MongoDB for storage purposes, but it builds on top of it, many of the features that are not native to the non-relational databases, but are useful, for folks like us that are coming from a relational database, right, and understands databases as having pointers and references and foreign keys, and we're looking for things that sort of behave like a join, but not quite. But it has similar features like that, right? So we'll come back to that a little later, perhaps on Friday. So let's create these sections. I'm just going to copy this. I'm going to paste it here. Okay, notice that it inserted one section. Let's insert another section. Copy. There we go. Enter. So insert that. Let's do another one. There we go. Let's do one more. Enter. Okay, so we should have the 4 sections. We can check. We can say show collections. And so now we have the users collection and we have the sections collection. Perfect. Okay. We can see their content. We can do db.users.find, and that returns both users. And we can do the same thing with sections. db.sections.find, and then we can pretty this. There we have it. So we have the 4 sections. We have section 1, 2, 3, and 4. We have 4 sections. Perfect. Each one with their own ID. Again, this ID was added by Mongo. Let's see. There's a question on the chat. It says, "Is find faster when using ID rather than non-key field?" Yes. Yeah. It is already indexed, right, from that key. Right. It's already using it for creating a tree, right, to be able to find things by primary key. You can create your own keys, right, and and index it by other fields, right? So certainly you can index it by name, seats, course, right, so that if you want to be able to find it quickly using other fields. And the same caveats apply that we saw in relational databases in MySQL, right? If the key is unique, then you will see huge improvements in performance. Right, if it's a non-unique key, right, you will see less performance, right, than a unique key. So same concepts apply here as well. Okay, so we created those 4 sections. Let's see what can we do with them. So one of the things, for instance, let's find the sections that have the course as CS101. Right? I believe there's 2. Yeah, these 2, right? There's 1 here and 1 here. All right, so let's do that query. Oops. Wait a minute. Oh, I did Control-C. Sorry about that. Let me bring back. Let's show the DBs. And so we'll say use whiteboard again. And let's copy this again. Copy. Let's paste this. There we go. So notice that we retrieved those 2 sections, and indeed it came back with those 2 sections. Right? We can maybe look at pretty. Actually, let me add pretty here next time around so that folks will be easy. So pretty. And let me make that just slightly bigger. There we go. Okay. Yeah, so there, I printed out those 2 sections, right? One with 12 seats and the other one with 23 seats. Okay. All right, let's keep going. So not only can I specify, here in the where clause, right, I can specify other predicates, right? Not only that the course is CS101, but you can be more specific, right? You can say, well, not only I want the sections, plural, the sections whose course is CS101, but I can specify even further, comma, right, where the seats is equal to 12, right? And if that's the case, there's only one section that meets that criteria, right, whose course is CS101 and the seats is 12. And so we see that specifying more and more criteria is treated as if it were and, right, where this is true and this is true. Okay, let's see. There's a question on the chat. Do we prefer pointers in NoSQL, or should we instead use a nested object? Yeah, right. So the question is, should we use references like this, right, where we might split data across multiple collections, right, and then data is being referenced between them, right, as if it were a relational database, and or we could, instead of splitting up content in multiple collections, we could have data that otherwise would live in different collections. One of the data in one collection could be embedded as a subfield of a bigger object, right, in just one collection. Yeah, and so as if you can get away with it, get away with it, you would stick with the with embedding objects, right? So bigger objects, objects containing other objects perform better than splitting it up into multiple collections, right? So basically, when you merge data in less collections, that means that you're doing less I/O, you're retrieving data from the file system, so that when you go out and fetch something from you'd rather bring as much information as you can from the file system, and copy it into memory, okay, as opposed to making many small queries to the file system, which are much slower, right? Because if you're doing a join, that means that you have to go to one collection, you have to go to another collection, right, and then do the dereferencing of references of one record into another, and that's much slower. If you could do one single fetch, retrieve that information into memory, and then do any processing in your CPU. And same thing applies when you are you're receiving communications from requests from the clients, asking for information. You want to minimize the number of hops, network hops, or queries that go from the client to the server, and because again, the slowest chain in any application is a communication chain, right? So you want to minimize that as much as possible. So if you are going to go out to the server to fetch any data, well, bring as much information in that one query over to to your clients, right? And then you do the processing in the client. So minimize the number of access to the file system, minimize any communication between processes. So if you, when I say if you can get away with it, is that sometimes you can't, right? Because you might have redundancies. So say you want so the alternative of having a reference to a course, the alternative would be to have the course, the actual course object embedded in here, right? And so that would be redundant, right? That would introduce redundancy because we have two sections that would contain the same information for the same course twice, right? And that course might have lots of fields in there, right? Who the author is, and how many, when was it published, and all the modules and the topics for that course, blah blah blah, all that information. You would not replicate it multiple times here within the sections. Instead, you would rather have that course implemented only once, and then you reference this from this section. So sometimes you cannot get away with it, but if you can, and you're not introducing any redundancy, and you can embed that data and it's unique data, then yes, by all means, don't split it into separate columns or into separate collections. Instead, embed it as sub properties. Good questions, excellent. Oh, it's getting hot in here. Just a second. Okay, so let's continue. Can everybody mute? Somebody has listening to a video. Can you please mute? Okay, all right, so let's keep going. You can so in this find, we just demonstrated, right, that if you provide several fields, right, they're treated as if they were and, right, where you're looking for documents who have this this pattern, that the course is equal to CS101 and seats is equal to 12. So it's an implied AND operator. Okay, but you can be very specific, right? Instead of this implied AND, you can be very specific and say actually use the Boolean AND, right? Or because what if you wanted to use OR instead of using this implied AND, right? So let's take a look at that. So inside of this where clause, right, you can get fairly complex. You can build very complex Boolean expressions. Again, things that you would expect to see in a where clause in a relational database, right? You can, in your where clause, you can be very, very, very complex. You know, this is equal to that, and this is equal to that, or blah 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 blah. And you can have all sorts of predicates in your where clause. So same thing here. So let's take a look at using that. For instance, one of the things that you can use is operators such as greater than, or less than, or equal than, greater than or equal, right? Where you can compare values, right? So let's, for instance, let's do this query. And again, this should have a pretty. Can't fit. Can't fit. Okay. Yeah. So let's copy this and let's paste it here. So then what this is saying is that I want to find those sections whose seats are greater than 30, right? And it comes back with 2 because this one has seats 34 and this one has seats 45. And we can take a look at all the sections. All the sections. These were all the 4 sections that we built earlier, right? One had seats 12, 23, 34, and 45. So in our latest query, right, we were retrieving the ones that had greater than 30. So it comes back with those 2, 34 and 45. So, and the syntax is that you provide first the field that you want to compare, right? So we want to compare seats, and then the operator that you want to use to compare. Now, there's a whole bunch of operators, right? GT stands for greater than, right? There's LT that stands for less than, right? All operators will start with a special character $sign. See that? So $GT. And then the value that you're comparing against. So it's 30 in this case. Okay. You can do an explicit AND, right? Where you can combine multiple predicates. Right. So let's do this one. Let's copy this over here. Copy that, and let's paste it over here. So this is saying, find me all the sections, and then notice the curly bracket here, and notice this AND. So this is an operator, a Boolean operator, and this is an array, and the array contains 2 predicates. Right? Here's the first predicate that says I'm looking for those sections whose seats is greater than 30, comma, and then there's another predicate. Seats are less than 40. Okay, see that? And these are an AND. So what this is going to do, it's going to iterate over all your sections and evaluate the seats to see if it's greater than or less than 40, right? In the AND, right? And then it's going to come back with those two. Oh, actually one. There's only one that is greater than 30 but less than 40. So there's only one. Okay, there it is. Excellent. Let's keep going. Yeah, so as I mentioned earlier, right, not only do you have pretty, you also have sort. So sort allows you to reorganize the content for viewing purposes, right? This doesn't actually reorder the content. It's very much like order by in SQL, right? So you can sort by seats, right? So this one is ascending, or you can do it descending by saying -1, right? So this one's ascending, 12, 23, 34, and this is descending, right? Going down. Okay. You can also create other modifiers. So you can, for instance, pass the sort. You can pass the sort to pretty, right? So that it modifies it twice. first it reorders it, and then it prettifies it, right? So that you get the prettified version of the sorted documents. Now, there's tons of other commands, right? These are the ones that you are responsible for. We will be using it in our assignment, and you get a chance to play around with them, but it's also available here in the document. So make sure to be familiar with these commands, but they're very self-explanatory. So there's equal, there is greater than, there is greater than or equal, there is in, we'll play around with in, less than or equal, not equal, and there is not in. There's a whole bunch of other ones that we're not going to be covering. These are somewhat the most common ones. That you can do. I would say 80 to 90% of everything you can do with these commands. Also, the Boolean operators. We just looked at and, but there's also or, there's not, and there's nor. Okay, and you can take a look at the documentation for all these operators. Okay. There's also, we're not going to be playing around with this, but I just want to let you know, very much like we have aggregation in relational databases that allow you to group records or documents by a particular field. You can do the same thing with these operators. You get this group, there's count, right? There's limit, there's skip, right? Again, so these are commands. You're not going to be asked about these. I just want to let you know that they exist, and I definitely encourage you to explore and play around with them on your own. Okay. All right. So let's keep going. So we know how to insert. We know how to retrieve data. Let's talk about being able to update or modify data that has already been stored in the database. It's already there. So, for instance, let's say somebody just joined a section number 2, so let's take a look at what the current number of seats are in section number 2. Okay. Oops, let's copy. There we go. So right now, section number 2 has 23 seats. Okay. So we can decrement or increment or just update the seats to be whatever we want it to be. Right. Now you have to be careful though here, right? So what if you did this, right? So many people would do the following, right? They would type this. It actually did it. Notice what it did here. So this says change, update, right? Update the section, right? So update takes 2 arguments. The update takes 2 arguments. The first argument is the filter, is the where clause, right? Where you can say, I want to update this specific section, the one whose name is 02. The second argument is the update that you want to make. Okay. And here we're saying that I want to make the seats to 22. Right? I want to make the seats 22. Actually, that's not the case. Right? What this is actually saying is saying that I want to replace the document that is already there. I want to replace it with seats 22. Okay, but it actually said that nothing was matched. Interesting. Why wasn't nothing matched? You see? Okay, seats still is 1. Let's take a look at the whole document. Okay, so the whole document contains name, seats, and course. Right. So the point I'm trying to make is that if I want to update it, I would type something like this. db.sections.update. Okay, what do I want to update? I want to update the section whose name is 02. There it is. What do I want to update? I want to update the seats because somebody just registered in the course, so there's 1 less seat, right? So seats 22. Now the point I'm trying to make is that you have to be careful, right? Because this is an error, right? If I do this enter, right, notice that it said that I was able to modify a document, right? There's exactly 1 document that was modified, but it wasn't modified as I expect. Let's take a look at the same let's look at the same document, right? And let's see what happened. Oops. What? Oh, yes. Notice that I can't find it anymore. Right? I can't find it anymore. Let's look at all the sections. Let's look at all the sections, and you'll see why we can't find it anymore. Okay. Notice that. Where did where'd my sections go? Find sections. Oh yeah, there it is. Okay. Here's the first section. Section 01. Here's the section. Notice what happened. Now we have a section that doesn't have a name, doesn't have a course. It only has seats 22. See that? So what I did with this update, what I basically did was replace this document whose name is 02, replace it with this data. And indeed, that's what it happened. See that? It changed, it threw away all the other fields, right? And it left us just with the field seats that is equal to 22. So it basically did what we asked it to do, but this was not our intention. Our intention was to modify just the seats, right? Not replace the whole thing. Okay, so this is definitely not what we wanted. Okay, so instead, what we need to do is to do the following. We need to use the operator set like that. See that? Okay, and then close it with curly curly bracket. Close it with a curly bracket. Okay. Well, actually, not name 02 because there is no section called name 02. So let's try another one. Let's try 03. So let's try with 03. 03. Oh, 03, which is this one right here, right? And it has 34 seats. So it turns out that somebody dropped off the this section. You know, they didn't like the course. They hate the teacher. So now we have an additional seat available. So let's change it into 35. Okay, if we do 35 like that, again, it tells us that it matched one record, right? Document, sorry. So let's take a look at all the section. And we'll notice now that the section 03, now we have successfully modified it to be 35 as opposed to replacing the whole thing, right? So be careful, right? What you want to do is use set, not just put in the field that you want to modify. Okay, careful. Okay. All right, so let's take a look at remove. Say we want to remove the section whose name is 02, although I don't think I have section 02 anymore. Yeah, we don't have section 02 anymore. So let's remove this one. Right? We'll do remove. So it'll be db dot sections dot remove. So remove takes one argument, right? And the argument is the where clause. Right? It says I want to remove something where, right, this is true. So I want to remove where, right, from sections. I remove where the seats is 22, right? I'm just going to blow away that document, and let's do that. So we can say the one whose sections is, I'm sorry, not section, seats is 22, right? So okay, note it tells us that one has been removed. We can look at the list of sections again and notice that there's only 3 now, right? There were 4 before. We've removed the one whose seats is 22. Okay. All right, let's keep going. Now, there's a whole bunch of other operations that you're not going to be responsible for, but I did want to let you know that they exist. There's insert one, there's insert many. Okay. You know, I encourage you to read through them. The only one that you're going to be responsible for is this one, insert collection, insert, which is the one that we played around with today. Same thing for update. There's a whole bunch of different versions of this, of which you're only going to be responsible for this update one. Okay. But again, I encourage you to read through the documents. And for delete, also, you're only going to be responsible for this one right here, the remove. But there's a whole bunch of other ones that are also useful as well. All right, let's talk about inheritance and generalizations, right? So if you remember in when we talked about relational databases, we also faced the challenge of having several classes that were inheriting from a base class, right? We had faculty and student. They were both users, and we found out that unlike object-oriented programming languages, relational databases just doesn't support specialization and inheritance. So the way we implemented it in relational databases, what we said is that the same fields that the top base class had, we're going to copy those same fields down to the other classes or the other tables, right? Remember, there was a couple of different alternatives the way we did it, right? We had the one table strategy, we had the multi-table strategy, the normalized and the denormalized strategies, right? That either split it into multiple tables and whatnot. So same thing here. MongoDB also does not support generalization and inheritance, and so we need to use the same types of strategies that we use for relational databases, right? For instance, the example that I'm going to give you here is that we're going to use I think we call it the denormalized strategy, where instead of having multiple tables, where each table had its own versions of the data, we're going to have one single collection, and then the fields that are implemented by derived classes are going to be implemented in the base table or base collection. So what we're going to do is, instead of having 3 collections, right, we're going to have just one collection, user, and then the fields that faculty has and the fields that student have, right, we're going to bring them over to the user collection. Okay, so that, for instance, and then we're going to have to have additional fields that are going to allow us to know whether this user is a faculty or a student. Whether should we treat this user as a faculty, or should we treat it like a student? Maybe a field called type or role, right? And then depending on the role, we can treat it as a faculty, where faculty might have an office. It might have fields such as whether they're tenured or not, right? Whereas a student might have other fields specific to students, such as maybe they have a GPA, right? Whether maybe they have a scholarship, right? So those are fields specific to students. Okay, so let's check out. Let's see how we can do this. So for instance, here we can update Ada. We can update Ada and maybe add a few fields that are specific to faculty. So for instance, we can add a field called type and say that type is a faculty, right? And we can add additional fields such as office. Since you're a faculty, you probably have an office. So let's do that. So let's take a look at all the users. So db users.find. And we have right now, we have Alice and Ada. So let's update Ada and say that Ada is a faculty. So we can say db.users.update, and let's update Ada. So we'll say we're going to update the record whose username is Ada. Okay, and what are we going to do? We're going to do in a set. We're going to do a set, and in this set, we can provide a field, right? We can say, oh, well, let's make you a faculty, right? We can say that the type of user is faculty. Okay. Notice that the update can be used for modifying fields or properties that exist. Maybe I want to change the username or the password, first name, last name. I can change fields that already exist, or I can add new fields if they don't exist, right? So in this case, we're indeed doing that. We're adding a new field called type whose value is faculty. Let's do that, right? Also, I can set many fields, right? I can set one field over here. I can set another field. I can say comma, and I can put other things. I can set other fields. So for instance, I can say that the office for Alice, right, is 132A. Yeah, 132A. If I do enter, notice that it said that it changed one record. We can do a find, and we'll notice that now Ada is indeed a faculty and has an office 132A. Make sense? Or I can insert a brand new faculty, right? We can say db.users.insert, right? And let's insert a user called T. Lee for Tim Berners-Lee. And then let's make them a faculty as well. So type faculty. And so he also has an office. So 133B. Okay, and we can look at all the users right now. And we have oh, I misspelled it. I'm sorry. Users. There we go. Okay, let's retrieve all the users. There we have it. So we have Tim Berners-Lee as a faculty, and so is Ada, right? With different offices. Okay. All right. So now, and maybe we can make Alice a student, right? So we can make Alice. Let's see if we can do db.users.update. The user whose username is Alice. And I want to modify and set the following. I can say set, right? And maybe say that the type of user that is at Alice is a student, and her GPA, right, is a 4.0. Oops, I have a missing parenthesis somewhere. Parentheses, I think, here. Oops, I have an extra curly bracket maybe. There we go, that worked. Okay, so let's take a look at all the users. Pretty, and we'll notice that indeed Alice is now a student and she has a GPA of 4, whereas you have these faculty. And the way you treat them differently is that you can use this type as a discriminator field, and you can do a db.users find by the type. Like find by the type, and we'll see all my faculty. There they are. These are my 2 faculty. Right? Or I can retrieve all my students. Right? And right now we only just have Alice as a student. That makes sense? Everyone still with me? Okay. All right. So let's talk about many-to-many. Actually, all right. So this is a big topic. Right. So let's actually leave it here, and we'll pick it up on Friday. Right. Any questions? No? Okay. All right, folks. That's all I had for you today. I will release the assignment soon, and we'll go over it together on Friday. All right. All right. Thank you, everyone.
Thank you, Professor.